Welcome to Pratidwani, where we try to humanize science. It is my delight and absolute pleasure to introduce you to the guest on this particular episode of Pratidwani, Professor Amit Agarwal. Amit is a professor of physics at IIT Kanpur, and he has been one of the most active quantum condensed matter physicists going around in India and probably across the world in various interesting aspects of quantum transport and quantum related devices. Uh, Incidentally, and I'm extremely happy to also inform that Amit has been awarded recently the Shanti Swarup Bhatnagar Award for Physics of 2025, and this is an excellent news. In fact, it so happens so that we are actually at the right time with the right person, talking to the right person, and more importantly, Amit's research interest actually has been over the years related to quantum geometry induced novel transport and optical properties of quantum materials. He's a specialist in density functional theory based exploration on 2D materials, topological materials, magnetic materials. Technologically relevant questions also is of his interest. More close to home for me is also the expertise he has in plasmons and charge density waves and various different kind of collective oscillations in solids, which also includes quantum materials, and of course, modeling of nanoscale devices, and many fascinating areas of research, which Amit has been exploring with his wonderful research group at IIT Kanpur. With congratulations, I welcome Amit to Pratidwani.
Yeah, thanks, Pawan, for the very grand introduction. I am myself surprised to know that I do so many things.
Yeah.
Okay.
This is all
Uh,
from your webpage.
yeah. But these are like, one problem at a time.
Yeah.
It's just that persisting over time
Time,
has
yeah.
them accumulated across domains, etc. And you make me sound like an expert, but I still see myself more as a student and explorer rather than expert, basically, right?
Absolutely.
And we keep finding surprises, small surprises in very mundane old problems also. Where when I was a student, I would have thought that these fields are already explored, but there are still gaps in the small gaps in the literature that we are happy to fill once in a while.
Fabulous. In fact, the Twitter profile of Amit, X profile of Amit exactly tells that he's by occupation a physicist, a professor, but by
Yeah,
inclination is a student. That's a
yeah.
very fabulous kind of philosophy to carry. So Amit, tell us a little bit about your origins. Where were you born, and what was your background, and how did you
Yeah,
get interested?
so I was born in Dhanbad in a typical business family. My name is Agarwal, right? So all of you know what Agarwals are known for in the country. All right. So small business owner. My father used to have a shop, etc. And I used to be a very average student till almost class seventh, I would say, actually. Okay. Around seventh, right? That means I would have been 11 or 12. I started realizing that if I do not do anything, if I do not study, then I'll have to, continue my father's business. And that was just not acceptable to me. So I thought, let's start studying.
Okay.
Okay. So I had to slog my way from being an average student in school to being one of the better students in school through class 8, 9. By 10, I was almost there basically.
Nice.
Okay.
Nice.
So one of the better students. And I then discovered that I by default like maths, I by default like sciences, etc.
Mm.
During this phase basically. And that allowed me to take sciences when I was class 2 student,
Mm.
etc. in my 11th, 12th. And then, as usual, the way out is to give JE and become an engineer, the national obsession, right? So
Mm.
I failed at that. Okay. And I was myself surprised because I used to think of myself as a very good student. But for those exams, you have to practice in a certain way, unless you've
Mm.
done time bound, very precise practices, etc. Even good students may fail, etc. Then I just decided to pursue BSc from Delhi University. So I was in Kirolimal College, which is the same as Amitabh Bachchan's college. I mean, just to
Two Amits.
Put it in context.
Yeah.
Um, yeah, right across Shahrukh Khan's college,
Mm-hmm.
which is Hansraj College, let's
Okay.
say. Uh, but yeah, so BSc was also pretty okayish. Without much effort, I did sort of okay in the Delhi University exams. But my discovery was that I actually really like physics actually during that those 3 years. It came naturally or it came relatively easy compared to my friends, let's say, etc. To me. So that is something that I liked. And at that time, I didn't know that one can do, a PhD in physics or, that PhD is a viable career.
Mm,
Academics is a viable career, etc. So this was 2002 around. So
mm,
2001 and 2002. So I prepared for these exams called MCA,
mm.
Master in Computer
Computer
Applications.
application. Wow. Okay.
Right?
Okay.
So these were the two popular exams, MCA or MBS. Okay.
Mm,
And I had some mental block that, MBAs do not add much value to the world. So, let's do MCA. At least it will be some technical work, etc. And I prepared wholeheartedly for a year for these MCA exams. I did very well in those exams, almost cleared most of the prominent national exams that year, etc. But since I had some liking for physics, I also give one of these few exams, basically
mm,
IIT Kanpur MSc PhD exam and
mm,
ISc
mm.
MSc PhD exam, etc. But till then, I wasn't sure what I'm going to do. Okay. But as soon as I heard that ISc, I have a call for interview, I went and I have cleared the interview. They've invited me to join the program. Then suddenly the wave function collapsed completely. I had no doubt in the mind that I'm going there, basically.
Nice.
That's how it started, basically, journey. So I meandered into a PhD, let's say. I didn't
Okay.
plan for it.
So,
I just, yeah.
how was the background at your home, Amit? Like, were you encouraged to take up science? I know you told about the back.
Yeah, no, no. So this was hard for me
Mm.
because I come from a business family and I was
Yeah.
the eldest kid. So nobody in my family had any background in education. Uh,
Mm.
but I mean, all of them were educated till
Mm.
BCom, etc.
Mm.
But nobody had any idea how to prepare for JEE exams or.
Yeah.
But my family was generally encouraging. If you want, we'll keep supporting you with whatever all emotional support plus all monetary support,
Monitors.
basically. So at
Nice.
least my family was well to do, etc. So that way it was very supportive. Okay.
Supportive. Wow.
But for BSc or PhD, I don't think anybody understood what I wanted to do. At
Mm.
that time, even I didn't understand what I wanted to do. Okay. And particularly when I started joining PhD, I sort of lied a bit. That this is a 4 year program. Um, PhD will be done in 4 years, etc. It was a 5 year program per se, but I actually 7 year, no, 2 + 5,
Yeah.
7 year
Integrated
program,
PhD. Integrated.
integrated PhD. But I sort of lied, it will take 5 years and I'll complete it in 4 years, etc. So we'll be done. Even though I knew that's not going to happen, I sort of, initially lied to my extended family. My parents knew, but they were
Yeah.
very supportive. But generally, when you tell others, you're always slightly defensive about it, basically.
Absolutely, absolutely. In fact, this happens a lot with so many people. You're absolutely right.
Yeah.
So, yeah, how was your schooling and college education? Was it also intense, or
Yeah. So my school turned out to be very good, actually. I know in retrospect
mm,
because my daughter goes to a KV here and I
mm,
can compare. And this is one of the better KVs in India, let's say,
India?
etc.
Yeah, yeah, yeah.
Apparently.
Mm,
Okay. So by comparing with her school and my school days, I know that that school was fantastic at that time.
mm,
Okay. And it played a huge role in my development. I certainly am very thankful for that. Plus, I had fantastic friends there. Who are all doing well across the country, across the world, etc. So it was as good as any school I could go to, and I'm very happy about that schooling. Basically, my college was pretty average. In a sense, ki nobody was really so in a MSc physics course, nobody was really interested in physics.
mm,
Okay. Except for my teachers, some of the teachers who used to teach well, nobody really cared about physics. There are only two guys in the whole batch who did PhD,
mm,
and one of them knew from the beginning that he will do PhD. He was the son of some scientific officer from
mm,
DRDO in Delhi, etc. And the other was me, who meandered into PhD, let's
mm,
say.
mm.
etc. Right? So that was broadly the journey. Okay.
Wonderful, wonderful. So,
Yeah.
uh, the transition from aspirational researcher to a researcher, uh,
Yeah. So
in
that's
into IAC into
yeah, yeah,
IAC.
yeah. So I went into a as a tentative student basically, right? Somewhere who's not sure of himself.
Mm,
Uh, but I was good at maths, and I knew I can hold on to myself given any program, basically. But other than that, internal confidence, I
mm,
really didn't have much to show for. And in my batch also, there are a lot of people from presidency, etc. Even in a small batch, there's a lot of show off, etc. Let's say, okay. And I was not comfortable with that. So yeah, but slowly as we started doing courses, etc., I
mm.
realized, irrespective of what somebody says, matlab, right? What they can do or what they do can be completely different, actually.
Different, absolutely. Yeah.
Yeah. So I just, yeah, started doing well in the courses and started gaining in confidence, etc. Slowly, basically. And I really admired my teachers. So specifically Diptiman, who later
Yeah.
became my boss also, etc. So I went to his first class in quantum mechanics. Okay. And the first thing
So
is, yeah,
before we go
yeah,
ahead, I should explicitly mention Professor
sure.
Diptiman Sen is
Yeah.
at IIC, is one of the very renowned quantum physicists, and also so many interesting questions and research areas in which he has worked on, including condensed matter physics, of course, but also broader context of quantum physics and
Yeah.
so many interesting
Yeah.
aspects.
Yeah.
Yeah, yes, yeah. Please
Professor
go ahead.
Diptiman
Yeah,
started his journey as a high energy
high
physicist.
energy physics. Yes, yes, high energy
So he's
physicists.
trained in Princeton,
Mm.
and he did high energy physics. But when he was hired in Center for High Energy Physics now, which
Mm.
earlier
Mm.
used to be Center for
See,
Theoretical Studies,
yeah.
CTS, he already told Professor Mukunda that he will shift to condensed matter. No?
Mm.
And at that time, there were great people like Professor Mukunda who said, we do not care what you do, but
Mm.
you're welcome to join
Mm.
our
Nice.
department,
Wonderful.
right?
That's such a
So
nice gesture.
yeah,
Yeah.
so all of these stories I heard later,
Yeah.
but my actually love for him started the first lecture. Okay, I go to his class, a young kid coming from Delhi University, first class I go to. The first thing he tells me, we are going to see quantum mechanics,
Mm.
and I absolutely don't believe in, philosophy of quantum mechanics. So if you want to discuss philosophy of quantum mechanics, please step out of this class.
Ah.
All I am going to focus on is becoming familiar with it, and
Yeah.
we'll do it, solve small problems and become
Mm.
familiar with it. And after this course ends, we can discuss the philosophy of quantum mechanics.
Yeah. Yeah.
And I was absolutely in love
Mm.
with that statement. No, yeah, small
Mm.
problem. Give me small problems. Let's do them one by
Let's
one.
do it. Yeah.
Etc.
Yeah.
Right? Yeah, yeah, yeah. And my batchmates started arguing with him, saying that, no, no,
Mm.
we'll do philosophy, etc. And he shut them down basically. Okay. But that was my first love with Diptiman, and I
Mm.
immediately sort of, started liking him
Mm.
immensely. Okay. And
Nice.
later, when I had to find a MSc project, I was very lucky that he had a opening, and I did my master's project with him, etc.
Wonderful, wonderful. So IIC also is not only a place where it will build you as a scientist, but also it actually molds you into a thinker because uh, having also kind of taken my coursework a long time ago, being a student at JNCSR, and also interacting with so many professors there, the atmosphere actually makes you rise up your game in a way.
Right, right,
So,
right. That
how
that is
was your experience, Amit?
very, very similar to that, actually. Yeah. So all the professors used to constantly challenge us, right? Come
Mm.
up with ideas, etc. And this was in absolute contrast to whatever I've been used to in college.
Absolutely. Yeah.
So
Yeah.
in the college, for example, the university, if you get last 5 years question papers,
Mm.
then you're sort of done. Well, for the
Done.
exams, you're done basically, right? Yeah. Here, nobody cares about that, right? There are
Yeah.
open book exams, there are, open notes exams, take
Mm.
home exams, etc. All they care about is, you do the problem independently,
Yeah.
and that's it, basically, right? Yeah. So I absolutely loved that, and I thrived in that environment somehow.
Wonderful. Wonderful. Wonderful.
Yeah.
So, give us a gist about the questions you got interested during that time. What kind of problems you already were motivated to address and
Yeah,
also
yeah,
got exposed to? Yeah.
yeah, yeah. So before that,
Yeah.
I'm a mentoring student actually. Okay.
Yeah.
So I wasn't sure what I'll do. I didn't go that I'll do theoretical physics from the beginning, etc. Right? So I started thinking what I'll do. So I had to
Mm.
first distill down between experiment and theory. Okay.
Theory. Yeah. Yeah.
Yeah. So I had integrated PhD friends, senior friends, let's say, etc. One of them being Avik Peth, who's in ISC as a
Oh,
professor,
yes.
right?
Yes. Yeah. Yeah.
Yeah,
Yeah.
2 years senior to me, etc. Their lab used to be our adda in the evening.
Mm. Mm.
And he and his would-be wife, Nagapriya, who was also a student
Mm.
in that lab, no?
Mm.
He did a good job of scaring the experimentalist out of me. Okay, so they will tell me stories about, how it takes such long time, 6 months to get an equipment,
Mm. Mm.
small parts which can be broken, and it can take so many months to fix them, etc. And in retrospect, I know it's a very good strategy because
Mm.
unless you really love it,
Mm.
that thing will scare you off basically, right? And it will send you wherever you want to go, etc.
True. True.
So because of this 1 month of this intense scaring,
Mm.
I decided that we'll do theory.
Mm.
Okay.
Mm.
And then I had to choose between, high energy physics or theoretical condensed matter, let's say, or astrophysics, etc. So I naturally had these choices of theoretical condensed matter or high energy physics, let's say, field theoretic based high energy physics, etc. Uh, I think I just liked Diptiman, so I went with condensed matter.
Mm. Mm.
Okay. And Diptiman was known to be a very reasonable guide, not very demanding, but not very
Mm.
lax also.
That's yeah.
Unlike a lot of other people who were like, you choose your problem, you solve your problem, and graduate. Diptiman was known for giving well-defined problems, and he has a very good track record of all students doing reasonably well,
Really, yeah.
even
Yeah.
at that time in PhD, etc. So I thought, I need a little bit of guidance and probably a easy guy to work with. And I was very happy. I was in love with him because of his teaching of our course on quantum mechanics, etc. So I was very happy when he just agreed in our first meeting that he'll be happy to take me as his master student. And then it just continued basically. Yeah. After my master's, I told him that I want to continue, and he said he assumed so, and we just
Mm.
continued to the PhD. So with him, I started working on problems related to interacting fermions in 1D, Luttinger liquid, quantum Hall edge states, and so on and so forth, basically. The first project was related to how interacting 1D wire, the conductance changes as I change interaction strength or I change temperature, etc. Basically, the interplay of some length scales of coherence, thermal coherence, and interaction induced some length scale,
Let's
etc.
scale.
Yeah.
So one of the crucial aspect I also have been kind of trying to do a little bit more of background research on
Mm,
the kind of problems you have been working
mm.
on. Dimensionality is one of the key questions you have been kind of thinking about for a long duration. I assume
Yeah.
even at the stage when you're talking about quantum wires and other
Mm.
things, that is a common thing I found is in some majority of your work, and it actually also has spilled over to so many interesting questions you have asked. We'll come to those
Right.
things later
Right.
on.
Right. Yeah.
What key elements of dimensionality? Because there is a very interesting interface, right? Because right at that time, let's say about 20 years ago, the problem of
Yeah.
looking at smaller dimensional mesoscopic systems
Mesoscopic
from a
systems.
quantum mechanics viewpoint actually was very critical. So
Yeah.
I
Yeah.
see that you've been doing that kind of a work. Could you please
Yeah.
tell us a little bit about that
Yeah. Yeah.
aspect?
So at that time, that field was actually called mesoscopic physics, actually.
Yeah, 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 yeah.
Right. And the idea is this interplay of length scales or dimensionality, basically, right? So the system has some dimensions
Uh-huh.
where the coherence length of the system is smaller or
Mm,
larger than that. Scattering length scale is larger or smaller than that, etc. You treat it as a quasi 1D system or
mm,
a proper 2D system, etc. So these were sort of interesting problems, and
mm.
accordingly, you got different kind of physics in
Physics.
this, basically, yeah. And prominent examples were a lot of experiments happening in quantum Hall edge states
Mm,
related to
mm.
this 2D electron gas in interfaces, semiconductor interfaces, basically.
Interfaces. Yeah,
Yeah.
yeah.
And later, after I graduated, graphene sort of emerged.
Emerged
Graphene
out.
actually emerged in 2005. So
Mm.
I was doing PhD around the same time.
Yeah,
Uh,
yeah.
so this was like a monoatomic layer of 1D atoms in 2D. and a lot of research. It gave rise to a completely new field, basically, sort of. Uh, right? Yeah.
Wonderful. In fact, I would be anyway linking your web page in the show notes. There's
Mhm.
also a beautifully kind of organized kind of documentation of everything, including Amit's PhD thesis PDF
I had
and
forgotten that actually. Yeah,
yeah,
yeah, yeah.
yeah,
I
and
had forgotten that. Yeah.
yeah, so there are so many interesting stuff. Of course, the PDF I don't know, maybe at least the thesis and the project, master project actually is already been
It should be
mentioned.
there actually. Yeah,
Yeah,
I remember once I had linked it actually. Yeah,
yeah.
but I had
Wonderful.
completely forgotten about it. I'm actually very fond of that thesis actually. Okay,
Yeah, yeah.
I wrote it with a lot of love, and
Mhm.
I was pleasantly surprised later when it received this best thesis award actually.
Okay, okay.
Okay,
Nice,
so I
nice.
was very happy about my thesis actually, and I didn't realize it then, but I used to like writing quite a bit
Mm.
actually. Okay, and that helps me now when I try to write better quality papers,
I'll come
etc.
to that. In fact, that is a key point in part of our
Yeah.
discussion because the one of the things which all students and anybody for that matter,
Mhm.
not just students, where one can learn from scholars like you is to actually know how to articulate abstract, complex kind of thoughts into
Right,
a language and also into a. It need not be only to the general public. It can be
right,
within
right.
even within the physics community.
Yeah, yeah, yeah.
So, Amit, looking at this kind of problems, for example, your own PhD thesis was on one-dimensional quantum systems, quasi
Correct.
one-dimensional, so to
Quasi
speak,
quantum. Yeah.
transport and other things.
Mm.
That is also a time where one was kind of in an era where the quantum technologies were yet to emerge completely.
That is
Uh,
correct. Yeah.
uh,
At that time,
uh,
this term was also not popular.
Exactly, exactly. In fact, but that's one of the reason I wanted to emphasize because all these things one could see that even way back in like 2008, 2009, when Amit actually graduated, even then a lot of groups within India were thinking about these problems. Just that now it
Yeah.
has become very, very
Right,
critical.
right, right, right.
So how was the kind of thought process then, Amit? Because see, I know at least within the research community, these problems were very, very fascinating, including let's say even soft systems. For example, even in conjugated polymers and other kind of
Right,
systems, there were so many
right, right.
questions being asked in the context of single electron transport kind of
Right,
an
right,
issue.
right.
So give us kind of a picture of that that era, so to speak. Yeah,
Yeah. So that era, I don't think we were motivated by any quantum technologies actually.
yeah,
It was
exactly. Yeah.
primarily driven by just pure research interest,
Mm.
basically.
Mm.
Right. And since I was a student, it was primarily driven by my boss's research interest.
Research area. Yeah, yeah,
Right.
yeah.
Yeah. At that time, all problems were interesting for us, meaning for a PhD student, right?
Mm.
And this I didn't realize that time, but this is a huge advantage actually to be
Mm.
that open-minded. Okay, if you are listening to your PhD advisor carefully and following, that's a huge advantage in your PhD. You will be much more productive than if you are always, have some friction in
Right.
either
Yeah.
alignment or in doing the work, etc. Right? So I had none of these issues. I was fully aligned with whatever ideas we started with, and then they
No,
took a life of their own, where
wrong. Yeah, yeah.
some of
And
my
you can
thoughts.
see that, and
You
you
know,
can see that how it actually also branches out. There are so many
yeah, yeah,
questions
yeah. No, no,
you
definitely.
mature.
Looking, so you put it in a very nice way, right?
Mm.
Play across dimensions, right? So
Mm.
from 1D in my PhD, I went to 2D in my postdoc, then bulk systems, and then once you have expertise in all of these, then you keep going back and
Quite
forth.
way. Yeah.
Not a plan, right? So a lot of these things happen randomly, and the
Absolutely.
only thing which really helped me, and which is one of my very strong points, which I realized 20 years after, is being very open-minded
Mm.
and very curious, basically, right? Yeah. So I'll not refuse doing a problem if I don't think that, well, if I think that I have not worked on it before, but if I'm just interested on it, I might work on it, etc.
Wonderful, wonderful. For listeners, I should mention that the whenever there is some kind of a quantum system like an electron which traverses through small dimensional materials like quasi one dimensional, meaning it can be a single wire where let's say
Hmm.
an electron transports through that wire. There are very interesting quantum mechanical effects which come into picture. And second point is it also relates to the Nobel Prize this year. In fact, it's very interesting
That
that
is that is
uh,
absolutely correct,
yeah, it's
actually.
also very interesting kind of quasi one-dimensional system, Josephson junction, etc.
Josephson junctions, yeah.
Yeah, yeah.
Yeah, Josephson
So
junctions, you can think of like 1D transport
transport,
in a
yeah,
superconductor.
superconductor.
Yeah. So
Yeah,
where there's a ring and you go around a ring which encloses a magnetic field, etc. So interference of quasi particles basically
quasi-particle. Yeah, yeah.
in the
So
1D.
Amit, now you finish your thesis. Like, what were you
Mm.
thinking at that time, and what was your futuristic perspective? And before we get into that, I generally ask this to everybody who
Mhm.
actually has kind of risen and matured into big researchers. Is how what were the main lessons you extracted out of your PhD? What was a broad
Yeah.
lesson, so to speak? Yeah.
So yeah, so that time it was all jumbled up, but now I
Mm.
can look back and think basically, right? Yeah. So so
Yeah.
one
That.
advantage of working with Professor Diptiman was he kept giving well-defined problems basically.
Mm.
Okay. So well-defined, I mean ki where matlab, we didn't know the answer, but where the initial half of the project's path was clear, let's say,
Very
etc.
nice. Very nice.
And this is a habit he has acquired somehow.
Mm.
That is his skill. Okay. So, with all his students, he kept giving problems which are solved within a year or so, basically. Right. So, that's what well defined becomes.
Mm. Yeah. Yeah.
So, all students, let's say if they are in 5 years, they complete with 6 papers, 7 papers, 8 papers, etc., and so on and so forth.
Wonderful.
That has been very consistent record
Consistent.
throughout all
Yes.
the
Yes.
students completed, actually. Okay.
I've heard so many people saying this actually
Yeah,
with
yeah, yeah.
respect to Professor
So,
Diptiman saying. Yeah.
yeah, yeah. So that is the most important lesson which is useful now for me
Yeah.
when I
Yeah.
guide my own students, that I have to frame problems in a reasonably well-defined way.
Mm.
Okay, so that is a background learning that I didn't realize that time, but it's very useful now, for example, right? Another very important skill I learned from him or during that time, we cannot solve a lot of problems initially, let's say, right? We're not able to think your way through.
Mm.
Then what is a simpler version of the problem?
Mm. Mm.
What is the almost trivial version of that problem, right? Which you can solve, no? You're not able
Wonderful.
to solve this complicated problem. How do you break it down into parts,
Nice. Nice.
right? And then I'll get some answer, let's say, by some solving, right? You can never be sure what is the answer, right?
Mm.
So what is the simplest limiting case where you can take, even if it is trivial,
Mm.
where you can show that the answer works or not works, basically, right? I can double check my calculation, but that is a biased check, no?
Yeah.
It is
Yeah.
my baby. I love the calculation anyway, right? So I have to be against it, no? How do I prove that this is wrong?
Mm. Mm.
As a scientific inquirer,
Yeah.
right? I have to distrust my own calculation, try to poke holes in them, basically, right? So taking
Nice.
limited cases, taking smaller cases,
Mm.
even simplified version of this problem helps build intuition where you know the answer, right? How do you
Mm.
bring it to that problem? And then you can, build on that basis. So
Build
this is
on.
a very important lesson, which I learned from him, which I didn't realize then.
Mm.
But that I keep using almost on a daily basis, basically, uh,
Wonderful.
throughout,
Wonderful.
basically. Okay. And the other lessons I learned is basically, how to be a nice human being, how to treat students well, and all such things, let's say, etc.
Such
Okay.
an important thing. Such so
Yeah,
it's
yeah.
such.
No, no. This has been like, my bread and butter.
Yeah. Yeah. Yeah.
I use them
No.
almost on a daily basis, actually. Yeah.
It is also, reflected in the number of people you have trained. If one
Yeah.
goes and sees Amit's webpage, you could see
Yeah.
so many, it's a sea of human, small sea of Kanpur humanity there.
Yeah,
It's
yeah. No, no, that
wonderful.
is absolutely correct, actually.
Yeah.
Yeah. And that is also another remarkable thing I want to highlight, actually. Okay. So, theoretical physics, a lot of people I know, even including
Mm.
my boss. So, this is not
Yeah.
something I learned from my boss, let's say.
Ah.
Okay. So, Diptiman at a time will work with 2 to 3 students.
Yeah.
Okay. Not more. So, you cannot have more than 3 PhD students at a time.
Mm.
Okay. Generally, he may have had some random time, but yeah. Generally not more than 2 to 3, and generally not more than one project student
Mm.
he'll have, basically. Okay. And his idea is he cannot pay attention or do all the
All
calculations
the. Yeah.
together, etc. Right. And a lot of people think that way.
Mm.
Almost all the theoretical physicists I know in India, think that
Yes.
way.
You're
etc.
right.
You can have work with at most three, four people, five, six people,
Mm.
and not more than. And people are really surprised when I tell them that my current group has 10 PhD students actually.
Yes, yes, yes. That's quite
And
fantastic.
sometimes that surprise is in a
Mhm.
well, I don't know, either they're making fun or they are really appreciating. I'm not sure actually.
Mm.
Okay, but I don't mind that. Okay,
Yeah, yeah.
as long as it is working for me
Exactly. Precisely
and
right.
I'm doing justice to the students, I do not care about what you are thinking, basically, right? Yeah. So this is
Absolutely,
another
absolutely.
lesson I want to impart, that each individual has their own style of
Mm.
working. And our job is to discover that style. So this is more relevant to younger colleagues
Mm.
who are, struggling, or
Struggling. Yeah, yeah.
who do not know, who are few years, 3, 4 years into this journey, academic journey of independence, and they have yet to find their style. I did
Mm.
not plan that I will work with 10 students at a time. Okay. Initially, if you had told me when I had joined IIT Kanpur in 12 that I'll be working with 10 students, I would have probably laughed at you,
Mm.
honestly. Okay. I started with one and I was dead
Mm.
scared to take one student.
Mm.
Okay. We had a senior colleague here, Professor Amit Datta. He helped me
Mm.
take my first student. Okay.
Yeah.
कि चलो साथ में स्टूडेंट लेते हैं,
Mm.
अ, तुम नहीं करा पाओगे तो मेरा इतना तो एक्सपीरियंस है कि मैं पीएचडी करा दूंगा, है ना? So that
Nice.
was how I started with my first student. No, he was very generous, and then after 6 months, he just drops into quietly in my office. Amit, I think you are handling the student well. Let
Mm.
me just sign off, in the guide. Right? So very generous senior colleagues, etc. Right?
Nice,
So it was
nice.
started like that. Then second student, third student. No. Then I graduated to 6, 7 students, etc. Then 1 year suddenly I had three master students whom I had trained as master student who were excellent, and
Yeah.
all three decided to stay with me. Okay,
Wonderful, wonderful,
and
wonderful.
I tried to scare the hell out of them.
Mm.
Okay, just like Avi can Priya can. Okay, PhD is hard, and getting jobs is hard. Maybe you should go think of going abroad, etc.
Mm.
They just decided to stay with me. You know,
Nice.
and since I was getting, I thought, okay, let me take a leap. If it works, fine. Otherwise, I'll scale down again. So I did an
Again.
experiment, and then it reached 10, basically, right? And then I found I'm comfortable with 10. I can manage 10.
Nice, nice.
Yeah. So that's where I am.
Wonderful. Wonderful, wonderful. In fact, there's a very, very important lessons for somebody to really, think through, and also, go back and check what way in which they can adapt these kind of principles. That's an
Yeah.
important aspect.
Yeah.
So, moving forward, Amit, tell us a little bit about your transition from PhD to postdoc, and where did you go, what did you do, and what kind of work you did.
Yeah. So PhD was mostly in 1D systems. My thesis is in quasi 1D systems, etc. So I got a postdoc, Marie Curie postdoc in Europe,
Mm,
Pisa. It's
mm,
a
mm,
fantastic group by Rosario Fazio and Marco
mm.
Polini. It was in
Yeah,
this
Polini.
Scola. Yeah, yeah. Scola,
Mm.
okay. A lot of work on plasmons, for example,
Yeah,
right?
yeah, exactly. Huge
Yeah.
amount of work there.
I
Yeah.
learned plasmons there.
There. Okay.
Yeah. So I went to this institute called Scuola Normale Superiore in this
Hmm.
absolutely fabulous city of Pisa. No?
Wonderful. Yeah.
And 3 years of postdoc, I became an Italian. I had a good salary. We really enjoyed our time there. I was already married during my PhD time, etc. And the project was working on interacting 2D systems.
Mm,
Okay.
mm,
So spin orbit couple, so effect of interactions on
mm.
2D spin orbit coupled systems. And then another problem I solved was superconductivity in the same 2D spin orbit coupled systems, basically.
Nice. Nice.
So
Nice.
so this is another remarkable thing. Okay. So working with Diptiman gave me that. So I
Mm,
had
mm.
8 papers out of my PhD. Okay. Which I didn't realize at that time, but it was remarkable. Uh,
Wow. Absolutely. Absolutely.
I struggle
Fantastic.
to get similar outcomes from my students. Okay.
Yeah.
With all my best intentions.
Yeah.
Uh, and I had two more from my postdoc.
Mm.
Okay. So one PRL, one PRB.
Yeah.
From my PhD, I had a PRL. So I just had 10 papers when I was directly trying to apply after 3 years of postdoc for jobs in India. Okay.
Nice.
Because the family, my daughter was already born.
Mm,
Even
mm,
though I had very fantastic job offers,
mm.
no? So you will know, one from Giovanni Vignale, for example, who
Oh,
himself
okay.
worked on plasmons,
Yes.
etc.
Yes. Yeah.
Right. And one from Marco himself, basically, offering me to stay there in Pisa for longer, etc. I just wanted to return back to the country. So I
I'll
have
come
this,
to that. I'll come
yeah.
to that. This is a crucial question because that is a question which is not something. kind of easily realized by people. But I'll come to that. I'll come to that. You please
Okay.
tell
Yeah,
that.
yeah.
Yeah.
So yeah, yeah. So that's what basic. So I had 10 papers, which made me roughly eligible to apply
Mm.
to a lot of these institutes in India, etc. And I wanted to come back. But I really enjoyed my time in Pisa. I used to say at that time that I'm an Italian. Okay. Coming back for a couple of, because I really liked their culture. They were very open.
Culture. Yeah, yeah. You're
I
right.
didn't
You're
know
right.
their language, but I never felt like people were, matlab I had any difficulty, etc. My family
Absolutely.
had a good time there.
Mm,
My
mm.
daughter was born there. So there were,
Wow, is it okay? That's nice. That's
yeah,
interesting. Mm, mm.
yeah. Okay.
Fantastic.
I think my
Fantastic.
daughter was born in India, but we stayed with her
Oh, stay. Okay, okay,
for
okay. Yeah,
1 year almost there, basically. Okay.
fantastic.
So yeah, so there I worked on these problems of 2D interacting electron gases with spin
Mm,
orbit coupling, basically.
mm,
So how does electron interactions change their electronic structure? How does it manifest in some transport properties? In superconducting phase, we discovered some new collective excitations. That was uh, work which appeared in PRL. That work was actually ahead of its time. Actually, I didn't realize that. So that was the background work for Majorana fermions. That time, if
Onions.
we become interested in Majorana fermions, it was almost exactly same system on which Majorana fermions, etc., were predicted around
Predicted and
similar time. Actually, yeah, but we had completely different motivation for that project. Mhm.
fabulous, fabulous. Now you tell me the crucial decision one has to make. Okay, what is the reason you came back, Amit? See,
Oh yeah,
given
for
the
me, it
fact,
was not even a decision. I knew this from the beginning, actually.
beginning, yeah.
Okay. Um, I don't know how, but I have a weird patriotic streak in me.
Mm,
I never knew it existed, but it has always
mm,
existed actually
mm,
somehow. Okay. So I'll tell you, for example, one of my limiting behavior when I was
mm,
trying to decide for PhD, etc., I decided that I'll do my PhD in India.
yeah.
So if you do MS from ISC, you get exposed, no, you can go
Yeah, yeah,
abroad.
yeah. A lot
Well,
of them have also gone. Yeah.
half of my batch also went, etc.
Mm,
Right? But I had this weird mental barrier that I'll do my PhD in India. No, and I
mm,
had just decided this. I do not even know why I had decided this. I advise my students against it now, for example.
mm,
Mm,
mm.
right? All my dual degree students, I'll tell you should seriously consider doing
Yeah,
PhD abroad.
pays
And
abroad.
not because you might find a better guide or something, but just because you will have a wider experience, you will have seen the
Experience.
world, and that is the age exit. Okay.
Exactly.
And you
Yeah.
might end up in a better group. That is a different thing.
Mm,
Okay. But at least you think about it in an open-minded manner and then decide.
absolutely.
Right. But I myself was very constrained at the time. I'll do in India. Okay. And if people had not bullied me by telling me that, when you apply for jobs, you will be judged on the basis of whether you have a postdoc abroad or not, trust me, I would not have gone abroad for postdoc.
Wow. Okay. That's interesting. That's very
Okay.
interesting.
And so all of my idealism clashed with reality, and I had a family to take care of,
Yeah, yeah,
basically.
yeah.
So I decided, yeah, let's go. But I had a very enjoyable time. Once I went, I realized, all of this mindset was not good, actually. One should really experience, etc. But I always wanted to come back. And what helped me with that decision was partially, I thought I was more capable than the problems I handled in my postdoc group, actually.
Mm, mm,
Okay. So there are uh, so, so I was employed through a project which was on 2D electron gases, etc. Right?
mm,
But at the same time, our group was working on a lot of problems related to quantum Hall edge states and on problems related to graphene, etc. And I was not part of those projects, basically. Okay. So I
mm.
thought, if I were independent, then I should have been part of these projects, etc. And I could contribute. Okay, so I was teaching Rutinger
Nice.
liquid stuff. A lot of my friends there, PhD friends there, etc., who were
Mm,
going and using it in the experiments that they were doing there, etc. So that was
nice.
one reason. But I anyway wanted to come back to India as soon as possible, and I thought, I'll struggle, but I'll start on my own. Mhm. And that is precisely what literally happened. I joined and I struggled a lot because I was slightly immature. I had not thought what I'll precisely do after I joined.
Mm,
So it took some time, but yeah. So that
yeah.
maturity took some time, but yeah, that was the decision basically. For me, it was no, well, I always knew, I'll
Come back and wonderful, wonderful.
come back and join
So,
it.
tell us now about now you come back and
Hmm.
you are setting up your group at IIT Kanpur.
Right.
Kanpur Physics Department. even the whole institution has one of the richest legacy in India,
Right,
and
right,
undoubtedly also across the world. Great
right.
physics department, wonderful researchers, and also a great scholarly kind of place.
Environment. Yeah, yeah,
Yeah.
absolutely.
So uh, how was it? How was it kind of getting induced into that particular place and taking it forward and
Yeah, yeah,
setting up a group, even though you're going into a great place, it is always
yeah.
an experience because you are
Right.
starting from scratch. As you mentioned, you had to think
Definitely.
through
Yeah, yeah.
everything and
But just before that, let me just tell you ki I made actually very logical list when I was trying to decide where I'll go.
nice, nice.
So I ranked all the institutes based on whatever,
Hmm.
quality of life, quality of physics, what my head says, what my heart says, matlab. Okay. So I had
Nice,
an Excel
nice,
file, yeah, no? And somehow after doing all this algebra, IIT Kanpur was number one in
nice.
my list somehow, basically. Okay. For whatever reasons, etc. And then when I visited IIT Kanpur for my job talk, etc., I was really impressed.
Hmm.
Okay, not with the infrastructure, etc., but all the people I met.
Hmm.
No, uh, we were discussing physics.
Nice.
So it can be advanced level or it can be basic stuff, something
Hmm.
they were teaching in the class, etc. But everybody was excited about some physics stuff. We discussed zero politics or zero what is happening elsewhere, etc. No, I was very impressed with that.
Hmm.
I mean, that had actually, if these guys want me, I just don't want to go anywhere else, actually. So I had a
Hmm.
very
Hmm.
positive experience of visiting IIT Kanpur. And luckily, very luckily, no, I thought that time I was extremely lucky that they also decided, ki, they can tolerate me
Okay.
and offered me a job, actually. Okay.
Nice,
So I
nice.
was very thankful to them for years, matlab, ki they did me a favor by giving me a job and I have to work to justify it.
No, no, and you've actually done it more than the expectation. I should mention, at least as a
Yeah,
colleague, I
yeah.
can just tell you that. That's
That I
wonderful.
also
Hmm.
agree now,
Yeah.
but so you won't believe, even in my first promotional this thing, no,
Hmm.
Mala,
Hmm.
I've always been very thankful to this institute, okay,
Hmm.
and I don't know whom to thank, Mala, where to express it.
True.
Okay, so during my first promotion interview, no,
Hmm.
I had a slide just thanking the institute for giving me an opportunity to join here. No, now it looks very weird to me, but I didn't know where to express it.
No, no,
And
it's
went
it's
well,
natural and it's also valid,
yeah,
because
yeah,
ultimately the environment in which you are anchored
yeah, yeah.
probably has the greatest effect on the work what you do
That is
without any.
absolutely correct. Yeah. And I learned everything I know, and all
Hmm.
the work I have done is from here, basically,
Yeah,
right? Yeah.
absolutely,
I
absolutely.
absolutely love this place.
Wonderful, wonderful, Amit. So
Mhm.
now let's kind of get an overview of the work, what has been going on, and also a few of the outstanding, papers from your group,
Mhm.
especially what I can, appreciate in a deeper way was the optical properties of the quantum
Mhm.
materials, and
Right.
some of the things what you and your group have actually found has been
Mm.
now kind of become very important to understand the nature of the geometry and topology of the materials, quantum
Right.
materials, from an
Right.
optical interrogation viewpoint. Because
Right.
in a very interesting way, you connect your numerical simulations and your theoretical analysis to an observable in the experiment,
Right.
which
Right.
is actually probably the hallmark of quantum condensed matter physics. And it is
Right.
in that way one has to really appreciate that. So give us a gist about that part of it.
Yeah. So this was a slow, conscious decision also, actually. Okay.
Mm.
As I started exploring theoretical, well, purely theoretical problems, etc. And initially, so the way theoreticians plot, I have a independent variable, and then, I see how does the quantity vary
Mm.
in terms of this independent variable. And initially, I also, like many of my other colleagues, etc., didn't even care, whether this quantity can be varied in experiments or
Mm.
not, etc. Okay. So after some point of time, I decided that, no, one needs to work more closely with experiments.
Mm.
And I started talking to a lot of experimental friends, basically. Okay. So in my profile, this transition will be seen in around 2018.
18.
Well,
Yeah,
there are
yeah, yeah.
publications with experimentalists, etc. But I
Mm.
started talking. you have to start talking couple of years before
Before, yeah, exactly. It
it
doesn't happen
manages
just right.
something. Yeah.
Right.
And that was a revelation to me, because the
Mm,
languages are completely different. Whatever I think of as a free parameter, malab, in theory, the experimentalist cannot even probe this. Interaction strength, for example. That guy has no way of, even tuning it in experiment, right?
true, true.
So uh, I consciously decided I will always focus on something which the experimentalist can change. So
Nice.
that is a conscious decision, and it was a long journey. Working with experimentalists really helped, and
Mm,
they also gave us a lot of problems. Basically,
mm, mm,
the system shows this kind of an effects. How do you think of it in terms of small models, etc.? Okay, so this transition happened because of talking to experimentalists
mm,
primarily. Okay. And currently, the research that you are talking of, the band geometry, quantum band geometry of
mm.
electrons, it has been there, but recently it has become more popular, like a
Popular.
new wave of a subject coming back
Mm.
again, basically, right? Yeah. And the job of us physicists, etc., is to catch that wave and, get
Right
as
on.
much
Right on
research
it.
done using even older methods, which we have
Yes.
trained for earlier, out of these basically, and train new students to do the
Yes.
same
Yes.
basic, right? Yeah. So the big problem is ki I have this properties which arise from electrons wave function.
Mm, mm,
Electrons wave packets in crystalline solids wave function, let's say, right? So these are properties like Berry curvature,
mm.
which can be thought of like a magnetic field in the momentum space, no? Which makes the
Nice.
electron move in weird ways, etc. And these band geometric properties coupled to external perturbations in whatever way you will probe the system,
System. Yeah.
temperature gradient, electric field, transport experiments, thermal experiments,
Mm,
or optical experiments, let's say.
mm,
So,
mm.
to say a few, there can be strain variation experiments also. All right.
Nice. Nice.
How do these perturbations give rise to some observable effect which capture these
Capture the, yeah, yeah.
electronic properties of the wave function, particularly? Right? So that's the broad question that we have been asking.
Mm,
And why only electron, matlab charge transport? It can be spin transport also more recently, or transport in other degrees of freedom, orbital, valley, and so
mm,
on. So this is the broad set of questions we have been asking. Okay. And one of them is the optical probe. If I shine
mm.
light in a system, then can we have some new phenomena?
Nice.
We have some
Nice.
new band geometric effect which we'll be able to see in experiment, and
Mm,
eventually we hope our interest is primarily in discovering this phenomena,
mm.
but eventually maybe some devices can be made out
Can
of
be
it,
made out.
sensors can be made out of it, etc., right? But we are
Absolutely.
really not pushing in that direction,
Mm.
but if somebody collaborates, we'll be happy to
Take it
push in that
forward.
direction.
Mm,
Yeah.
mm.
I also have a lot of work on devices actually, which is in collaboration with electrical engineers here.
Yes.
So
Yes.
that's another remarkable thing of IIT Kanpur, no? When I joined, if you would have
Mm,
said that, Amit, after a few years, you will be working with an electrical engineer, I would have probably laughed at you.
mm, mm.
Okay? And that's where open-mindedness comes in. Okay. So we were just having a faculty dinner somewhere, and a colleague from electrical engineering, Yogesh Chauhan, a very good friend
Yeah.
of mine,
Yes.
he asked me, yeah, I'm looking for somebody to, analyze quantum transport with me. I work on this classical device-based transport,
Mm,
and who'd be a good person to talk to.
mm,
And I thought about it, and I told him, see, we have colleagues here. Professor Tarun is there. You can talk to them,
mm.
etc. But I am also not bad. That's, no, no, that was I was younger, so I was not that
Yeah.
confident. Okay, so I said, okay, let's discuss and then we try, right? Yeah.
Yeah, yeah,
And then we
nice.
started discussing, and the discussion was fun.
Mm, mm,
But this was another challenge. So since my philosophy was not formed,
mm,
I was getting a lot of advices from all sources, basically, right? Do not collaborate with engineers.
mm. Okay.
Do not do computational work.
Mm,
Do not collaborate with your postdoc bosses, etc.
mm.
This is
Yeah,
the initial first 2, 3 years of yeah, no.
yeah, yeah.
And since I was a bit underconfident, I had not definite formed philosophy.
Mm,
I struggled with this a bit actually, ki what to do or
mm,
what not to do, etc. Okay. But eventually, what really helped was one advice I got from a very wise source. And
mm,
the advice was prominent in its simplicity. No, I
mm.
mean, do you enjoy it?
Yeah,
If you enjoy it, please do it. And that really saved me because I thought about it. And yeah, if I enjoy it, let me do it. No,
wonderful. Wonderful. Mm,
right. And then I'll see if I stop enjoying it, I'll not do it. But since we were kept learning new things, etc., I kept enjoying it actually. Okay. And that is how I learned density functional theory. That is
Nice.
another aspect. If you had told me a theoretical physicist who likes
Mm,
analytical models, okay, a theoretical physics trained in a high energy physics department,
mm.
okay, who has done field theory courses and who has been
Yeah,
trained in field theory courses, etc. Right? I like
exactly.
maths
Yeah.
very, yeah, modeling, right? You would have told me that you would do complete simulations. I would have probably laughed at you in my PhD or
Mm,
even in my early days, etc. But as we were solving these device problems, we realized material properties become very important. We are always
important.
taking them from some paper or the other, and
Mm,
all materials do not have very well-defined papers basically written on them. So we thought, okay, let's learn this, and then we found another colleague from material science here. The beauty of
nice.
IT is being
Mm, mm.
cross-discipline, and learned DFT with him, Somnath Bhaumik. No?
Nice. Nice. Yeah.
And currently, three of us run a small group together, basically, where students are can be either from physics or electrical engineering or material science,
Material science.
solving problems which are at the interface.
Fabulous.
Yeah.
Fabulous.
So that's another aspect of being open-minded and taking
Exactly.
advantage of opportunities which arise.
That's a key word, open-mindedness.
Yeah.
That's a and the ability to learn new things, because
Yeah.
that is something which is very, very crucial, actually. Yeah.
Yeah. And what really worked was all of us were of similar age. We joined around a similar time.
Mm, mm,
So there was no tussle of, credit. He did
mm.
more work, he did less
Okay.
work. Some project, his domain, he'll take
Mm,
care. So
mm.
so we developed into a very beautiful friendship also
Nice.
over
Nice.
time. So yeah. Mhm.
Fabulous, Amit. This is actually, it's very illuminating to also learn that, you know, you have been actually kind of asking questions which expand your kitty in terms of the techniques, and
Right.
also simultaneously working on relevant problems. Because I can see
Right.
that as you have been always anchored in, of course, the physics, like
Yeah.
fantastic condensed matter physics, but also expanding it towards devices, towards new problems which are arising,
Right.
etc.
Right. So there are three aspects to this. I want to
Yeah,
tell specifically for a lot of younger colleagues,
yeah, yeah,
etc.
exactly. That's what yeah, that will be great
Because
to actually
I
know.
struggled with all of this. Okay. So number one is this was a conscious choice.
Mm, mm,
Now it looks sort of obvious and easy, but it was a conscious choice, and I worked over the years for it actually.
mm,
Okay, to do this. Okay. Number two was open-mindedness and not
mm,
listening to a lot of other colleagues, and even not listening to myself actually.
mm,
On
mm,
mental blockages, I sometimes had to, "Okay, let's see, see if we enjoy it or not. Let's give it a month and then we will see." But I kept enjoying it actually. So as I was
mm,
learning DFT, I realized that, every time we ran into a problem,
mm,
I sort of enjoyed it, how to solve it, and, we evolved through it, etc. So we came as an outsider, for example, right, with
mm,
experience in DFT, and we so once we had solved this material science problems, etc., we were already doing good. Then I realized, why are we not solving physics problems
mm, mm.
with this, right? And that was the phase of this topological materials, etc.
Materials, yeah,
So we
yeah,
picked up that wave, and I think, had a reasonable output, I would say. And it
yeah,
also
yeah.
helped me collaborate with a lot of friends and experimentalists, basically because of that.
This is a fabulous work, in fact, related to berry curvature in the collaboration with Mandar Deshmukh's group.
Yeah,
And I also see that there are subsequently many papers you've written on similar topics
right.
as
So
a
that's the
follow-up.
interesting story, actually, I want to tell.
Yeah,
Okay.
yeah, please tell,
So
please
the
tell.
Mandar collaboration is very, very interesting, and I'm very thankful to Mandar for this collaboration, etc. I have learned a lot of things, physics-wise, out of it, actually. Okay, and a lot of other aspects of doing research also I have learned because of this collaboration.
Yeah,
Okay. Yeah. So the
yeah,
interesting story. So some
yeah.
year, I forgot which year, but they had a very nice paper on in Nature Communication on non-local Valley Hall effect
Mm,
measurement
mm,
in
mm.
some twisted double bilayer device, etc. And it was around December, November. I think their paper came, and December. So December, and I typically have this habit that 1 week I take to think about what we did this year and what
Nice.
we will do in the next few years, etc. So broadly plan and analyze basically,
And
and criticize myself actually. Okay, so actually criticizing is the main goal,
main.
and
Mm,
then of course build from there, etc. Okay, so I was thinking these guys are doing the best experiments on whatever this
mm,
materials,
mm, mm.
related to Berry curvature physics in India. Okay, And people didn't know, but I definitely thought, yeah, I'm the best person to model this phenomena. Well,
Phenomena. Okay.
I know more about this than anybody knows. That time we didn't have that many papers on it actually, but we were working, so I knew. Yeah, etc.
Nice. Nice.
I just drop him a mail basically saying that,
Hmm.
you guys do the best kind of experiments on this stuff, and
Hmm.
we are doing the good theory on this. Here's
Hmm.
a new phenomena which has recently been predicted, and people are
Hmm.
after it. Couple of papers I attached, and have a look. If you are interested, we can have a discussion. So just
Hmm.
quote mail basically. Till then, I had not even met him
Okay.
ever. And he was also equally open-minded. He just got
Hmm.
back within a couple of days saying that, this looks very interesting. Let's have a discussion.
Hmm.
So we had one discussion, and this is like year end, no, 27th or 28th, something like that. We had a discussion, and they said we'll do this experiment. We already have the device in the fridge, etc.
Wow. Okay. Okay.
So initial signature they saw within 2 weeks, etc. of this nonlinear Hall effect. Okay. Then of
Nice.
course it
Nice.
took us a long time to understand that
Hmm.
and
Hmm.
build around that, etc. But that's how it started basically, right? So that's a remarkable story in terms of being open-minded and
Open-minded.
also
Absolutely.
reaching out
Hmm.
to friends basically. Well, that time he was not even a friend, but reaching out to, let's say, people,
Yeah.
etc.
Yeah.
And I learned that they had very good work ethic, very systematic way
Hmm.
of
Yeah.
writing
Yeah.
papers. I learned a lot from them, etc. And very being very conscious about the quality of paper writing. So I
Hmm.
was already
Hmm.
getting there, but I learned a lot of things from their group actually, and I was very happy about it. Yeah. So rarely do you find groups which are working at a higher level than my group was already working at, even at
Hmm.
that time, basically, right?
Hmm. Hmm.
I would say in all my collaborations, his is the only group which was at that time
Like,
working at a higher level than
level. Okay.
we were basically. So we were happy to see that, yeah, more effort is needed.
Nice.
So
Nice. No,
somebody,
that's how
yeah,
you up your game also many a times.
that's how you up your game also. You need more
Hmm.
stamina, right?
Yeah.
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 Where we stop, a lot of people will begin from there.
Begin from there.
Yeah,
Exactly.
yeah,
Exactly.
yeah, yeah. So that
Fabulous.
was a very
Fabulous.
nice learning actually. Yeah.
So,
Okay.
Amit,
Mm,
give us also an overview now. We are almost coming towards the
mm,
conclusion.
mm.
Kind of future projects, what you're trying to venture into, what are the questions you are looking into,
Yeah,
and what kind of directions you would be taking forward.
yeah. So that's a very nice question,
Mm.
but all my answers are commensurate with the constraints I have currently.
Yeah, yeah, yeah.
Okay. So there are a lot of constraints. Now it is not longer a constraint, but we were constrained with computational facilities for some time.
Mm,
So
mm,
I reduced work on materials, etc., and focused on modeling transport phenomena, etc.
mm,
Right.
mm,
So I'm reasonably good in that sense. Ki I can work within my constraints, etc. Okay. I complain a bit, but not much, not enough to disrupt the work,
mm,
basically,
mm,
etc. Right. Yeah. So we'll do more work on material aspects. So density
mm.
functional theory based predictions of yeah, uh, transport phenomena, let's say. So you discover a new phenomena, right? But you want to
Nice.
make accurate prediction of which material is the ideal one for it, for example, right? You do experiments on this material, you will see in your lab. So I want to be able to tell you that basically. That's my main. So my real love is actually predicting new phenomena,
Phenomena. Yeah, yeah.
discovering some new effect which can be tested in experiments. Okay.
Like
And
resonant second harmonic generation as
this
a probe
generation, yeah. That
of quantum field.
definitely
That's a
is one.
fabulous work. That is a very,
Yeah,
very
yeah.
interesting piece of
So
work.
even more interesting. So that of course is there, but I thought this was sort of, I was praising myself on the back. So
Mm.
last year, 24 beginning, we had a paper on nonlinear Valley Hall effect.
Non-linear, yes, yes, non-linear.
Okay.
Yeah, yeah.
And this year there are already couple of experimental papers on that actually. Okay. So I'm not part of those,
Mm.
but they see exactly same phenomena. Then more people are writing papers explaining other aspects of that paper, etc. So
Very
that I
nice.
thought was stuff of, what I used to admire when I was a student in ISC basically, right? So
Mm,
people
mm.
be very happy about, we predicted this phenomena, somebody discovered, etc.
Yeah, yeah.
Yeah. So we are reaching there, basically. Um, so that was very
Wonderful.
nice example. Okay. But yeah, so we keep working within the constraints of giving well-defined problems to the students.
Mm,
And okay, so the one advantage of working with a lot of students is even if each of us do parts of the problem, if the supervisor has a broader view,
mm, mm.
then you coherently solve a bigger problem,
Bigger problem.
but not
Absolutely. In
in
fact,
one setting, but by doing small parts of
small one.
this. right? So
In,
there'll be a lot of PRBs, let's say, once in a month, PRLs, etc. A lot of experimental collaborations also, which feed into this as a feedback loop. What you're doing is right or not, and then that suddenly you realize that you've solved a really big
big
problem.
problem.
Okay.
Beautiful, beautiful.
For
Yeah.
example, I recently realized that we have a fantastic understanding of second order nonlinear transport and
Address.
optical phenomena in quantum materials, basically. Right. All aspects of it, actually. Okay. That is really surprising. We understand it in the degree of detail, which is hard to come by,
Come by,
right? But like
exactly.
over 3, 4 years, basically, of a lot of work, actually.
True,
Right?
true.
So likewise, I'm now building on work on spin transport and orbital
Hmm.
transport, for example. So this will show up in the next few years,
Few years.
I'm guessing. Yeah. Okay.
That's
And
a
I'm very
great,
open-minded. I like changing directions. So I won't be surprised if I start working on something else
something else.
together, etc. But actually, the trunk of the tree remains the same. The
Same,
technique,
exactly.
you can keep adding to them, but you just
Mm.
keep applying them to newer set of materials, newer set of
Material.
phenomena which will arise, right? Yeah. So now, for example, altermagnets are very popular.
Mm.
So there are waves of this materials, right, which keep coming once in a while, right? Yeah. So there was this graphene,
Mm.
then topological materials, then Moire materials,
Material.
right? Now altermagnets, right?
Yes,
So
yes.
the same kind of physics you'll keep seeing in different
Seeing
materials.
in different materials. Yeah, yeah,
But if you
true, true.
understand the core really well, then you will keep building on these to give output wherever needed, basically. Okay.
Fabulous, fabulous.
And in future, we'll probably do more devices,
Mm.
not motivated by this NQM or India's
Mm. Yeah.
but once you understand the basic fundamental physics reasonably well and you can predict it for realistic materials, that's a natural direction to go.
Direction to go. Exactly, exactly.
How do you make it useful, basically? So,
Useful.
lots of theoretical predictions. Okay.
Fabulous, fabulous.
Yeah.
So,
So this,
Amit, before
yeah.
we
Mm,
stop, I
mm,
one crucial aspect.
mm,
There's a lot of learning to do from the way you think.
mm,
You're choosing research problems, writing,
mm.
and what is your work ethic? That is an important point where a lot of students might be interested in knowing it. And because it's not something which you would have developed only in a day. It's a
Yeah, yeah,
lifelong thing.
yeah, yeah. That is
Uh,
absolutely correct. Yeah.
so the process of thinking about it, how like time you spend on research, can you tell us a little bit about it?
Surely, surely. So I
Mm.
have a fantastic work ethic. I did not realize it then,
Mm.
but it is just from my childhood, seeing my parents work.
Yeah, yeah, yeah. That's
Okay,
true.
so the kind of so I cannot sit idle.
Mm.
Okay, so either I'm spending time with my family or preparing for my teaching or
Mm.
thinking about research. These are
Research.
the issues I spend time on, basically. Yeah, and that's about it, basically. Yeah. So I meet a lot of colleagues, and I can almost say that not many people can outwork me.
Mm.
Honestly, not in a sense of boasting. I would
Yeah.
actually like to see some people who can outwork me.
Mm.
Then I have to step up my game. Uh,
Fabulous. That's an
but
excellent.
well, I have so reasonably good work ethic.
Mm.
I also liked having more number of students because it actually
Mm.
forces me to work more.
Work more. Yeah, yeah. I can understand. That
See,
depends actually on the bandwidth. You're absolutely right.
yeah, yeah.
Uh,
So there's a right balance between see, you want to be personally involved in a project, right? You want to know all
mm.
aspects of it, the maths of it, the physics of it, the boundaries of the assumptions, right? Because the students are mature, but not as
Not
mature as
yet.
the guide in all aspects, right? Yeah. So I want to be the one who still drives that.
Mm.
Okay. Even though I'm very happy if some student points out something new,
New.
remarkable, etc. But I still drive the boundaries of the project
Mm.
and most of the writing of it, actually. So I still
Nice.
edit all my papers, actually. Okay. In fact,
Very,
I've been
very
saying this in a lot of forums, the best writer in the set of collaborators, no, should always spend time finalizing the paper,
fine. Paper. Absolutely.
basically.
Absolutely.
Okay.
That's
And
that's
that's another
crucial.
thing I do not see in a lot of my colleagues, friends, etc. Not enough
Yeah,
time
yeah.
spent in. So even if we write a PRB, I am
Mm.
very happy with the quality of PRBs we put out, actually.
Yeah, yeah, yeah. No,
Uh,
it's also constancy, right? I've not.
yeah,
It's
yeah,
not
correct.
like that's a very important lesson while doing research because there is a lot more to achieve if you are actually constantly thinking about it, and you can really do a lot of big things by
Right, right,
constant effort. You're
right.
absolutely right.
Yeah. So the this Bhatnagar Award or
Mm.
some I also recently got this Academy Fellowship,
Yeah, yeah, yeah.
the
You're right. Yeah.
Nasi,
Mm.
the Allahabad Academy.
Hello.
But
Yeah,
these successes are sort of recent and they do not affect the work in any way.
yeah, yeah.
Okay. That will sort of continue actually, just because you set up a system and you stick to it somehow basically, and you sort of enjoy
Absolutely.
doing it actually. So that is the main thing. So I have come to the kind of work that I really enjoy doing.
Enjoy
I
doing.
have built up the group in a way I really enjoy managing.
Absolutely. Absolutely.
So I would like to keep doing it basically. Yeah. Mm.
Fabulous, Amit. There is so much to learn because uh, even when we actually had interacted earlier, there were
Yeah.
so many interesting interactions. At least one vivid meeting in Bangalore, which we had during
Yeah.
the,
Yeah. But very
the
brief actually. Yeah.
very brief, yeah, yeah. But
Yeah.
it was so nice. Actually, it was very interesting to learn so many interesting things. And of course, I've been reading many of your papers which come out
Mhm.
especially related to plasmons, something which is very fabulous. So
Mhm.
this is just a start. I know that you are so energetic and also, so motivated to do so interesting and high quality work. And I'm very sure there will be a lot more
Yeah, yeah.
interesting things to
That is
come.
another thing. Let me take 1 minute to point this out,
Yeah,
actually.
yeah,
Okay.
please, please.
Most of
Yeah,
us join around 35, let's say. We join around 32,
yeah,
33,
yeah.
but let's start from 35, right? If you are in ISR or IITs, etc., or ISC, then 65 is the retirement age,
Retirement
let's say.
age.
So 30 years roughly, right? The midpoint of that is 50.
50. Yeah, yeah.
So should we slow down before the midpoint? Come on. No, that
Yeah,
would
yeah,
be what a
exactly.
waste, right?
Absolutely.
Irrespective of whether you have become professor or not, right?
True, true.
You have started to decay before your half-life. Come on.
True, true. No, see, you're absolutely right. And, if you correct for the transformations and also developments in medical technology,
Hmm.
so at least per capita, the life expectancy of an Indian actually has changed. So, which
Right,
means
right, right.
things
Yeah.
actually are going on a
But but still service duration remains fixed. So I
service.
don't,
No, no, no.
yeah.
Yeah, I mean to say
Yeah.
the ability to think about
Yeah,
questions and
yeah,
other things.
correct, correct, correct. Yeah. So I'm actually, yeah. So actually, yeah. So the incentives is another problem. A lot of us
Mm,
get beaten down by life. We have some or the other problems, etc. We lose touch for a year or so
mm,
in
mm.
some cutting edge areas, etc. And then it's sort of hard to come back. That I
Yeah,
understand.
that's right.
Okay. But we do think in the broader context that it's a
Mm.
30-year career roughly. So we cannot go out before
Absolutely.
25 years. Matlab, we can start winding up, but not before 25, 30 years, basically, right? Yeah. Uh,
Absolutely right. Absolutely right.
if we can, then even 30 years, we should be, on full firing mode, basically.
Firing mode. That's true. That's
Right.
true.
Yeah. Yeah.
No, thank you very much, Amit, for your time. I know because you are in the limelight now, and I should mention to the listeners and also the viewers that incidentally, Amit was kind to agree to come on podcast even before the announcement. So
Yeah.
after
Yeah.
that, I immediately hurried, telling that let's do it quickly because it's a ripe moment to actually do. I'm very thankful to Amit
Yeah, yeah.
because
I in fact wrote a WhatsApp message to Pawan blaming him that he knew the results beforehand. So
I
he is
wish.
too late already. Okay.
I wish I could time travel and do things like that. But
Yeah.
anyway, congratulations, Amit,
No, no,
for
thanks a
the
lot.
achievements. But more importantly, congratulations for the very interesting work what is coming out of your
Yeah,
group. In fact, that's the most
definitely.
important aspect. And I'm also kind of positive that so many students will get motivated from learning from how you're thinking and how you're doing. That's important. Yeah.
I am actually always looking for bright students, good
Yeah.
students,
Yeah.
etc. Okay. I may not have most of the time fundings for postdocs, so I have to refuse. But
Yeah.
bright students to apply and come, you are willing to work for me, I'm happy to help actually. Okay. And so a lot of opinion I may have expressed a bit strongly. Uh, if you like it, please think about it. If you do not like it, please excuse me.
No,
I apologize, etc.
not at all. Not at all. In
And
fact.
that depends on the viewers,
Viewers,
basically.
yeah, yeah,
Yeah,
yeah.
yeah, yeah. It may not be your cup of tea, etc. But
Mm.
this is how I think broadly. Okay. And a lot of these awards, Bhatnagar Award or
Mhm.
this academic fellowship, I look at them with the same spirit as I look my joining of IIT Kanpur,
Right, cut. Nice.
with a lot of gratitude towards the community, honestly, actually. Okay. And the thought process is ki, you gave me this huge respect.
Hmm.
Now I have to live up to it.
Live up to it. Yeah.
And I have to sort of, show it in my work, basically, that I really appreciate it. Okay.
I'm very sure people who have been associated with you, your students, your teachers would be very proud of
Oh yeah, yeah. So that I know actually. Yeah.
you. Yeah,
So
yeah.
Professor Diptiman was extremely happy about this recent
Wonderful.
developments, etc. And yeah, I'm very happy about that.
Great, Amit. Thank you very much for your time.
Yeah.
It's been a fabulous, almost an hour, more than an hour, where we actually have taken your time. I know you are really at the cream of your cream of
No,
the
no, don't worry about
requirement.
all. I'm always happy to talk to
Right.
younger colleagues.
Yeah, yeah,
Anyway, some message can be, if I can be helpful in any way,
yeah. Yeah, definitely,
I'm there.
definitely. In fact, we'll also have you later on sometime in the podcast to also discuss more about specific aspects of your problem which
Sure,
you're
sure.
looking at. So thank you very much for your time, and I'm wishing you all the best for all the ventures going
Thank
forward.
you, Pawan. I'm very happy to talk about this.
My pleasure, my pleasure. This is Pratidwani, where we try to humanize science. This time with the one and the only Amit Agarwal. Thank you, Amit.
Thank you, Pawan.